So we're still forming equations. I think of a number, I write x. I add 8 to it, plus 8. The result is 14, equals 14. Find the number. Well, here's the equation. X plus 8 equals 14. X must be equal to 14 minus the 8. X is equal to 6. Which makes sense. If I think of a number 6 and I add 8 to it, I do get 14. The next one, when 3 is taken from 5 times a certain number, remember we're using x as our certain number, the result is the same as, equal to, as adding 6 to twice the certain number. So my equation looks like 5x minus 3 is equal to 2x plus 6. And so we go to solve the equation. We've formed the equation. We've read the story. We've formed this equation here. So if that's the case, gather your x terms. 5x minus 2x is equal to this 6 plus 3. So 5x minus 6, 3x is equal to 9. X is equal to that 9 over that 3. X is equal to 3. And we also met with these examples in this chapter where we kind of run two numbers side by side until we equate them to some value and find what the number is. For example, one number is 5 greater than another number. If the sum of those two numbers, this number and that other number, is equal to 59, finds the numbers. So, we said that one number here is 5 greater than the other. We've added them up, and as we add, we gather. So we've x plus x is 2x, is equal to this 59 minus the 5 here. So we've 2x is equal to, that should be 54. So if 2x is equal to 54, x is equal to this 54 over that 2, x is equal to 27. For examples here, the first one, Anne is 5 years older than Mary. So we have Anne and we've Mary, and we say that Anne is the number of years of age, x, plus 5 if Mary is just a number of years of age. So Anne is plus 5 years older than Mary. If the sum of their ages is 51, so Anne's age is x plus 5, and Mary's is just plus x, is equal to 51. Find the age of each. Well, we gather our x's again, and we have 2x, and we bring the plus 5 over to this side, so we get 51 minus 5. That means that 2x equates to 46, so x must be equal to 23. So Mary is 23, Anne is 23 plus 5, Anne is 28. Similarly, Alan is x years of age, so we write his age, and his father is 3 times as old, so the father is 3 times old, so that's 3 times x. If the sum of their ages, Alan and the father, x and 3x, is 64, find their ages. Well, x and 3x is 4x, that's all equals to 64. This x must be equal to that 64 divided by this 4, the coefficient of the x. X is equal to 16 years, so Alan is 16 years of age, and the father must be 3 times that, the father is 48. So we'll finish this chapter just by looking at how we can use algebra to find the lengths of shapes of sides of different shapes. So the first example we'll look at is this rectangle, okay? And we know it's a rectangle because we're using this mathematical notation of the single dash on this side and this side means that those two sides are actually equal in length. And the double dash here and the double dash there mathematically means that this side is equal in length to this side. Okay, so let's write an equation for this first shape and find the value of a. Well, if this side is equal to this side in length, that means 4a plus 5 must be equal to 3a plus 12. And that's the equation. Let's solve for a. So let's gather the a's. 4a minus 3a is this 12, is equal to this 12. plus that 5, which becomes minus 5 as we move it over the bridge. So 4a minus 3a is a, 12 minus 5 is 7, a is equal to 7. If we look at the second example here, we have an equilateral triangle where the three sides are of equal length, and we're told that one side is, in terms of a, is 2 times 3a minus 2. The other side is 4 times 4a minus 3. So again, we're trying to find a. So we can just equate one side to the other because we know they're the same length. So 2 all multiplied by 3a minus 2 is equal to 4 times 1 in brackets 4a minus 3. So let's remove the brackets. 2 by 3a is 6a, 2 times minus 2 is minus 4, 4 times 4a is 16a, minus 12. 4 times minus 3 is minus 12. So let's keep the larger a's on the right. So we have 16a, bring over this 6a becomes minus 6a. Let's write what we have here on minus 4. Let's bring over this minus 12 to here, it becomes plus 12. Minus 4 plus 12 is 8. 16a minus 6a is equal to 10a. So if I just come up here, therefore if 8 is equal to 10a, then a is equal to this 8 divided by that 10. Or it's the same as 4 over 5. That's the value of a. And finally, we'll look at this example here. Actually went from 1 to 3 here, but they're all the same approach for all of them. In this isosceles triangle here, where two sides are of equal length and they're marked here, 7a plus 4 is equal to 3a plus 24. So that's straightforward enough. Equate one to the other, gather your a terms, gather your numbers. That means 4a is equal to 20, a is 20 over 4, a is equal to 5. The only real difference between this problem and this problem here was that this problem required you to remove the brackets. So always be careful, removing the brackets, multiply the outside term by all terms inside, and always be careful of the signs.